Hey guys, how are you? This is Mr. Chavla, and in today's video, I'm going over the Algebra 2 Common Core exam from June 2017, and this will be the key for part 1, numbers 1 through 8. Alright, so it's the June 2017 Common Core Algebra 2 exam, part 1, numbers 1 through 8, the first 8 multiple choice questions. So let's get right into it. The graph of the function p of x is sketched below. So this is the graph of p of x sketched below. Which equation could represent p of x? So what I'm going to do, guys, this is similar to what you guys would have had in Algebra 1, Common Core Algebra 1, where basically you look at the zeros, right? Where the graph crosses the x-axis, you see we have a scale of 1. So I'm going to mark those. So one of the zeros is at positive 2. Another one is at positive 3. And then another one's at negative 3. So we have x equals 2, x equals 3, x equals negative 3. Now remember, whatever the zeros are, the factors have to have opposite signs. So p of x could be represented by, if x equals 2, it gives us x minus 2 as a factor. X equals 3 means we have x minus 3 as a factor. And x equals negative 3 means we have x plus 3 as a factor. All right? Because if we set x plus 3 equals 0 and solve, that's how we get x equals negative 3. If we set x minus 2 equals 0 and solve, then we get x equals 2. All right, so we want to see which of the choices give us something of that nature. So if we look at choice 1 gave us p of x equals x squared minus 9 times x minus 2. If I factor out x squared minus 9, it's a difference of squares. We get x minus 3, x plus 3, and x minus 2, which is the same thing. Again, it's x minus 3 and x plus 3, x minus 3 and x plus 3, and x minus 2. The order in which we multiply by the commutative property doesn't matter. So I'm not going to bother looking at the other choices when I know choice 1 is correct. All right? Because that's all. We don't need to look at the other ones, all right? We're going to move on to number 2. So number 2 was interesting because they're giving us an exponential equation, but they're giving the solution in terms of the natural logarithm base e. So they're saying what's the solution to 8 all raised to the, 8 times 2 with 2 being raised to the power of x plus 3 equals 48. So I'm going to show you guys how to solve this using the natural logarithm. We don't need the calculator so far, but all the answer choices are in terms of ln, the natural log, except for choice 2, which is x equals 0. So if I look at number 2, guys, 8 times 2 all raised to the x plus 3 equals 48. If I divide both sides by 8, I get 2. I'm going to put the 2 in parentheses now, raised to the x plus 3 power equals 48 divided by 8, which is 6. Now, I don't know why they insisted upon using the natural log, but now when you take a log on both sides, right? So if I take the log, well, natural log, right? And natural log, then what ends up happening, guys, is I could take the exponent, and you got to know this rule, guys. It's this taking the log of any base of a number raised to an exponent is the same as just having the exponent, x plus 3 in the front, multiplied by the log, in this case the natural log of whatever the base was, which is 2. So we're rewriting it in that form. And I don't need the parentheses here with the 6, because I'm going to make sure it looks the same way that it did the answer. So now if I divide both sides by natural log 2, I get x plus 3 equals natural log 6 over natural log 2. Then I subtract 3 on both sides to get x equals natural log 6 over natural log 2 minus 3, which is choice 1. Natural log 6 minus natural log 2. I'm sorry, natural log 6 over natural log 2 minus 3 is equal to x. All right, so we got that right there. That's it. We could use the calculator to confirm a few different ways, but don't worry about it. Let's go to number 3. Cheap and Fast. That's a beautiful name, huh? Cheap and Fast. Cheap and Fast gas station is conducting a customer or consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? So they want to know which of them would lead to a biased sample. So let's look at each one. Choice 1 is interviewing every fifth customer. That's the sample to come to the station. That's kind of random because you don't control who's gonna come in, and you don't know who's gonna come in. So that's gonna get you a random sample. So I need to stretch my neck for a second. I was sitting in an awkward position, but that's pretty. That's not biased. So I'm not gonna pick that. Choice 2, interviewing customers chosen at random. Anytime there's random, most likely it's not biased. Chosen at random by computer at the checkout. That's very random, unbiased, right? The sample selected will be representative of the population in terms of how satisfied they are with the cheap and fast gas station. Now, choice 3, interviewing customers who call an 800 number posted on the customer receipts. This will always create bias because you're only interviewing the people who called. The people who called will take the time to do so because unless they really like service, because they have a very strong opinion, whether it's positive or negative, but that leaves out a lot of other people who didn't call, right? So this is voluntary response or self-selection bias. We could say voluntary response bias or selection bias. So the answer is choice 3 for question 3. All right, choice 4, interviewing every customer who comes into the station on a day of the week chosen at random out of a hat. No bias there. All right, what you want to understand is surveys and how bias can arise. What are the different types of bias? And one of them is voluntary response or self-selection bias, where the sample is self-selected. It's the people who called because they chose to call. All right, I'm going to minimize me now so we have room to look at the work we need to do for question 4. The expression 6i cubed minus 4xi, let me start over. The expression 6i cubed times negative 4xi plus 5 is equivalent to, we could simplify 6i cubed first, but I'm going to just distribute instead. I take that back. I'm going to simplify it. Guys, so I is equal to the square root of negative 1. I square is simply equal to negative 1. Okay? I cubed is equal to negative I. So this is the same as 6x times negative I, all multiplied by negative 4xi plus 5. This becomes negative 6xi times negative 4xi plus 5. So now when I distribute, negative 6 times negative 4 is 24, x times x is x squared, and I times I is I squared. Then I distribute over the 5 and I get negative 30xi. Now, since I squared equals negative 1, right? So I bring everything else down. This just becomes negative 24x squared minus 30xi. So that means it's not choice 3 or 4, it's choice 2. Negative 24x squared minus 30xi. Right? And choice 1 obviously doesn't work either. But choice 2 is the one that works. All right, moving on to number 5. So number 5, you have to be a little careful. All right, I'm going to actually go into the smartboard so that I have space. No, I'm going to erase this guy, so pause the video if you need to. I need to clear up space. I'm not going anywhere. I'm not going to the smartboard. I like this one notebook right now. Nothing wrong with the smartboard, but this is what I've been using and this is what I'm going to stick to for now. Okay, if f of x equals this 3 times the absolute value of x minus 1, and g of x is equal to 0.03x cubed minus x plus 1, an approximate solution to the equation f of x, which was the absolute value one, equals g of x, which was the polynomial, is, so guys, remember, usually when you have a system of equations where there's more than one equation, the solution set is when you graph both equations to the point or points of intersection, x comma y, but when you have function notation, guys, they want to know what the value of x only that makes f of x equals g of x, because this makes 3 absolute value of x minus 1, that's our f of x, is equal to 0.03 x cubed minus x plus 1, and if there was a way to solve this algebraically, I don't know that there necessarily is, and I don't feel like doing that right now, and neither should you in this case, because this is a calculator question, but basically, if you were to solve, is just asking for x. So we want to be careful. Anything with an ordered pair, meaning x comma y, is out because a solution is only talking about the x value. Now, there's more than one solution. Let's find out what they are. So I'm going to go into the graphing calculator. There's also an equation solver feature in some calculators. If you use the Casio, there is, but this has more than one solution, so I wouldn't rely on that in this case. So I'm going to go to the graphing calculator. Now, in most calculators, you could only enter F1, I'm sorry, Y1, Y2, right? But in this one, what I love is this is the Desmos graphing calculator. You could actually type in f of x and use that. So we have f of x and we have g of x, which is this funky polynomial. And I want to make sure I get a good view of the majority of both graphs, right? And all their intersection points before I do anything else. See how this blue graph is going up? I don't know if it's going to intersect. That's the polynomial g of x. I don't know if it's going to intersect the absolute value graph in red again. So what I'm going to do is I'm going to change the setting in my calculator. Meaning on the y-axis, the numbers need to be more spread out. So let's say we go from -20. We don't need to go that low because if you see here, the red graph doesn't go below that, so I don't need to go that low on the y-axis. So let's just say I go down to -10 like I was before, but up I need to go higher. So let's say if I go up to 20, what happens? I still don't see if the red and blue graph intersect because I want to know if they intersect again. So I'm going to go even higher to 40. And you see how they're getting closer? So I'm going to continue. I don't know how high this goes. Maybe I need to increase the scale on the x-axis as well. Let's look at the choices. So one of the choices is 1.96, the other one 11.29. I should have looked at that first. So I'm going to use a scale from -10 to 15 on the x-axis. Now that's what I needed to do to see the intersection point. So guys, we have 3 intersection points. We want to see which of those has one of those as the x value, right? So let me fix, sorry about this, I'm trying to just make this clear. Okay, so now I could fix this so we could have a good window, right? You'd have to figure out how to do that in your calculator, right? I kind of just typed them in here. So we just go from -5 to 20. And on the y-axis, we don't need to go so high. We'll go from -10 to 40. That's fine. That as long as I see all the intersection points. There's not going to be more than 3. So 1, 2, 3. So just the x values, right? One of them is -0.99. Another one's 0.50. If I round to 2 decimal places, another one's 11.29 or 11.3. And as I see, 11.29 is one of the x values. That's right here. So that's my answer choice, guys. One of the solutions is x is equal to 11.29 or approximately, because they said one approximate solution, an approximate solution, right? One of the values of x that makes the two functions have the same output is about 11.29. All right, let's move along to number 6. Given the parent function p of x equals cosine x, which phrase best describes the transformation used to obtain the graph g of x equals not cosine x like p of x, right, but cosine of x plus a minus b if a and b are positive constants. So basically they're saying a is more than 0 and b is more than 0, right? So p of x is just equal to cosine of x. I'll put the parentheses, right? G of x, it's not just any transformation, it's a translation, which means it's shifted. It moves left, right, up, down. So inside parentheses, we're adding a positive value. Whenever you add a positive value, it moves to the left. So it's left a units. Whenever you add inside the parentheses, it moves left. If you subtract in the parentheses, it moves right. So since we're adding inside the parentheses, it moves left a units, which eliminates choices 1 and 2, which said right a units. Then outside is the vertical translation, moving up and down. So since b is also positive, adding b would make it move up b units, the graph of p of x. Subtracting b moves, I'm going to move down b units. So it's down b units, so it's choice 4. All right, left a. and down B. That's all there was to it, guys. Just understanding the rules for translations. All right, it had nothing much to really do with the cosine itself. Number 7, a solution to the equation, or the solution to the equation, 4x squared plus 98 equals 0 is, there are a few ways we could do this. We could use the calculator. We could use inverse operations in a few different ways. We can't really factor this. We could use the quadratic formula. What I'm actually going to do is I'm going to use inverse operations. So here's what I mean. We start off with 4x squared plus 98 equals 0. I'm going to subtract 98 on both sides of the equation to get 4x squared equals negative 98. Now traditionally, guys, what I do is I would divide 4 on both sides, but I found out whenever the leading coefficient of x squared is a perfect square, it's easier to just take the square root on this step. And you'll see why in a minute, because what's going to happen is we won't get radicals in the denominator. So the square root of 4 is 2, and we want to make sure we include the plus minus here in front of the other symbol, right? And when we're taking the square root of the number without a variable, the square root of 4 is 2, and square rooting x squared just gives us x. Square root of 4 is 2, square root of x squared is just x. Now I'll take the square root of 98, but negative 98. What you want to make sure is that your calculator is in complex mode. So I'm going here to my numworks calculator, and what you need to do is, so I don't know how you do it in your calculator, but most calculators do not start off in complex mode. They are in, they only allow real numbers. So what I need to do is I need to go into complex, and it started off in real. I actually switched it into Cartesian because here it says a plus ib. I don't know if you could read it from here. So I need it to be in complex mode. So now when I take the square root of a negative number, it's not going to say non-real error, right? I forgot this wasn't the calculator. I could type in SQRT for square root. Right? And there's a way to do it by hand too, but these dots in the middle mean multiplication. So it's 7 times radical 2 times I. But I'll just call it 7i radical 2. But it's both the positive and the negative. So you guys see what I'm saying? That means we eliminate choice 1 because there's no I. And same reason for choice 3. Now if I divide both sides by 2, I get x equals positive and negative 7i radical 2 all over 2. Positive and negative 7i radical 2 all over 2. Again, positive and negative 7i radical 2 all over 2. All right? So that's how we could do it by hand. The quadratic formula is very easy for this one too, since the b value is 0 if you have ax squared plus bx plus c equals 0. But it's the same thing at the end of the day. You could have used the calculator as well, but it's useful to know how to do this by hand. I'm going to move on to number 8. Which equation is represented by the graph shown below? Well, let's look at the choices since it's multiple choice. And we see that these are all cosine functions. Cosine, 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 cosine. And we notice they're all of the form, they all have the form y. Typically we have y equals a cosine of b times x plus c, right? If you look at all these equations, the c value, the midline is 0. So c equals 0. And we could see that the midline is the middle value, the middle y value is 0 every time. The maximum is 0.5 and the minimum is negative 0.5. So c is just the middle value, the middle y value, or the average y value of the cosine curve. Right, so this is our midline, just happens to be the x-axis, is also our midline, where y equals 0. The amplitude is the distance that the midline, that the curve increases above the midline and decreases below. So remember the maximum is 0.5. So here's our maximum y value, which we hit twice. The max y value is 0.5. So we go up by 0.5 and we go down by 0.5 to the minimum, which is negative 0.5. So our amplitude is simply the distance that we increase and decrease from the midline. So our a value the absolute value of A is the amplitude, I'll call it amp, is equal to 0.5. So A has to be either 0.5 or negative 0.5, or which is also 1/2. So since none of these have a negative A value, we know A has to equal a half. So based on what we have so far, all of them have a midline of 0, right? So basically, it needs to be of the form y equals 1/2 cosine of bx, right? And we need to find out what b is now. So a equals 1/2. That eliminates choices 4 and 2. And we don't need this 0 here anymore. Okay? So now what we want to look at is the period. That's one way to look at it. The period is the distance, and we know the amplitude now, right? So the a value has to be a half. That's why we're left with two choices, 3 and 1. The period is the distance on the x-axis it takes to complete one full cycle. So here you see we start at the maximum. We come down from the maximum to the midline, which is where y equals 0 in this case, and then it goes from the midline to the minimum. See how in the amplitude we went down by 0.5 to go from the midline, from the maximum to the midline, and down another 0.5 to go from the midline to the minimum of negative 0.5? Now we go back up. So it went down from maximum to midline to minimum, back up to midline, then back up to its starting point, which was at the maximum, and then it would repeat another curve. So the period is right here, is pi. Pi is the period. So P equals pi. There's a relationship. The period times the frequency is always equal to 2 pi. Since the period is pi, pi times b equals 2 pi, dividing both sides by pi tells us that b equals 2. So we have to have a 2 here. This is what the equation has to be. 1/2, y equals 1/2 times cosine of 2x. Y equals 1/2 times cosine of 2x. So answer is choice 1. Y equals 1/2 times cosine of 2x. Y equals 1/2 times cosine of 2x. Y equals 1/2 times cosine of 2x. Just making sure they match. All right. Next question. I know I said we'd only do 1 through 8, but I think we could fit at least one more. All right. A manufacturing company has developed a cost model. C of x equals this crazy polynomial where x is the number of items sold in thousands. So let's keep that in mind in case it's important. X is the number of items sold in thousands. So if x equals 1, that means 1,000 items were sold. X equals 5 means 5,000 items. Now, the sales price can be modeled by S of x equals 30 minus 0.01x, a linear function. Therefore, the revenue is modeled by R of x, R for revenue, equals x times S of x, where S of x was given, right? The company's profit, P of x equals R of x minus C of x, can be modeled by, so they want to say which of these is equal to P of x. So first thing is we want to simplify R of x, right? So if R of x is equal to x times S of x, then that means that we're going to multiply x by all the terms of S of x. Well, which isn't a lot, 30 minus 0.01x. So we distribute the x and we get R of x equals 30x minus 0.01x squared, right? Now we want to do R of x minus S of x. So R of x we already know to be 30x minus 0.01x squared. And now we want to subtract C of x. So we're going to subtract C of x, which is this crazy polynomial, 0.15x cubed plus 0.01x squared plus 2x plus 120. Okay, when we're subtracting polynomials, the negative sign, you could imagine there's a -1 here. You multiply all the terms by -1, so all the terms change to the opposite sign of whatever, and since they were all positive, they're all going to become negative. So we get negative 0.15x cubed, and I'm going to erase this distribution. We don't need this here. So x cubed minus 0.01x squared minus 2x minus 120. And I'll bring down the other terms. We don't need the parentheses anymore. So we have 30x minus 0.01x squared. Now I just want to combine like terms. 30x and negative 2x are like terms, and I'm going to write the polynomial in standard form, meaning the exponents will decrease from left to right. So we got negative 28x, and there's no other x term, so anything that doesn't have negative 28x is out. So this has positive 28x. I'm sorry, anything that doesn't have positive 28x is out. So this has negative 28x, this has something completely different, this has 32x. So since 1 is out, 3 is out, and 4 is out, what's left? 2. But let's just work it out so that we could attend to precision here and show that our answer is, that is the messiest 2 I've drawn in a while. Huh? There we go. So let's just combine the other like terms. So I'll use a different color highlighter. Negative 0.01x squared and another negative 0.01x squared. Those two are just going to combine to be negative 0.02x squared. Right, so far everything else is good. We have negative 0.02x squared plus 28x. Now the other two terms, the negative 0.15x cubed has no like term, so we just bring it down. Right, so we took care of that. I'll just highlight it to show that we got rid of it. So that was this one we took care of, right? And then the negative 120 also has no like term, so we're just going to bring it down. So this is what we should have. Negative 0.15x cubed, I'm just going to highlight in whatever color now, right? Then we have the other two terms which we highlighted earlier, minus 0.02x squared plus 28x. Then minus 120. So it is indeed choice 2. All right. I'm wondering if I should continue the video or pause here and resume in another video because I'm trying not to make the videos too long. I think we're good, guys. So, hey, I didn't want to make the video too long. 1 through 9. Number 10, I'm going to start in the next video. All right. Take care, guys. Good luck. This is Mr. Chava again. And this is the June 2017 Algebra 2 exam, and you just saw us go through number 1 through 9 of the Part 1 multiple choice section.